Welcome back to part 2 of lesson 9.2, dealing with graphs polar in the polar coordinate system. And this second part is going to focus on the rose graphs. And if you'll notice, these equations are r equals, radius equals, it does not have r squared. And if you'll notice, the thetas are multiples. They are either even or odd numbers, and that's going to help you determine the number of petals. So if you have a graph, and if you look at the two graphs that I gave you here on in the notes, this particular graph has, this one is a cosine graph, and if you'll notice, it has an even number of petals, and then if it has an even number in the equation, then you're going to have 2 times that number in petals. If you notice, if it's a cosine graph also, these petals are on the axis. If you have a sine graph, those petals are not on the axis. Okay, just a little side note. If you have a graph that has an odd, n is an odd number here for the theta, then when you have that graph, it is going to have just that number of petals. So if n is 3 or 5, it's going to have 3 or 5 petals, or 7 petals, or 9 petals. And here it is the cosine here is symmetrical to the pole again, to the theta equals 0. So just as the one up above was, this one is not. You notice how this one kind of is symmetrical to the y-axis, or to that pi over 2. It's not a y-axis in polar system. It's at pi over 2. So let's go ahead and sketch some of these. They're kind of fun. You can also do this on the calculator and overlap them, and you got the color calculators. It's a lot of fun too. So let's first look at these where you have an even theta, which means you have 2 times that number of petals. So here you're going to have 4 petals because you have 2 times 2, and they're going to be, the petal length is going to be 6. That's what that is. So if we go out 6, 1, 2, 3, 4, 5, 6, and I have 4 petals, that's pretty easy. 1, 2, 3, 4, 5, 6, 6, 1, 2, 3, 4, 5, 6. You'll get to see how off my graph is. But we're going to draw so going north there's a little short, but there we go. Okay, this one would have how many petals? It's going to have 12 petals, right? Because we're going to do 6 times 2, and the petal length is 12. No, petal length is 8, right? We have 12 petals, they're 8 long. So each of those were 6, and if I have 12 petals, that means I'm going to need, let's see, if I do 1 on each axis, that's 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to need 1 on each of these, so that's coming out here. That's probably too fat because I'm going to need 2 more like through here, right? Yeah, those are too broad. Too broad. Make them narrower. here and here, right? And then you get the idea. We're just going to come out here and go back, and come out here and go back, and come out here and go back. Yeah, my drawing is definitely not to scale, but they're not that bad. Ah. All right, I said that. It still looks pretty funny. All right, so key thing is that you have the right number of petals and that you've got the length about where it needs to be. Ta-da! That's not too bad. Okay? And you can overlap them. Okay, but I had an odd, let me draw my purple. The purple highlighter needs to be a little darker. There we go. All right, let's look at these. If you have an odd theta. The odd theta is just that many petals. So this is going to have 3 petals, and the length is going to be 4, okay, and this one is symmetrical to the pi over 2, okay, and so if I have 3 petals, let's see, I did that one in green. I think it does. How long are they? 4. 1, 2, 3, 4. So kind of doing this number, and then 2, 3, 4, 3, 4, kind of that thing. Oh, it looks kind of funny, but that's what it looks like. Okay. This one would have how many petals? It's going to have 5 petals, right? And it's going to have a length. They're each 6 long. And it is symmetrical also. Symmetrical to the pi over 2. So that one, if they come out 6, and I only have 5 of them, it comes out here, and then it's going to do here, here, and then over here. Something like that. What color am I? Orange. There we go. All right. We will spend some time in class, sorry about that, playing with these in the calculator. It'll be easier to show you on the calculator in class. Please feel free to spend some time doing them on your own. I've written down a few notes here to help you when you're doing them on the calculator, in that you will want to expand the theta. Well, first of all, let me show you something really quick. When you turn on the calculator and you're in the mode, you need to change back down here. Instead of function mode, you need to go over here to polar coordinate mode. And that will help give you the polar graph and the polar coordinates, okay? And we will do this last graph in class. When you come and this is a fun one to do, but I would like you to write down this change, something called the theta step that will show you how close it graphs it, the increments. The smaller you go, the more accurate your graph will be. I usually do pi over 24. I make my x's, especially for these spirals right here. You'll need to make it really, really big in order to see anything. And that's why I even went larger than 2 pi, so that you can see it spin around, okay? And just make sure, here's a list of the different graphs. You need to make sure that you can do each of these graphs and that you can identify what the different parts are, and you can match the type of graph with the equation. I'll see you in class. We'll get to do some of these together.